Hello Internet, welcome back to our asteroid ring shader. We're going to not make this much of a shader anymore. What I mean by that is we're actually going to get into a few scripts to do sort of what I've got up on the screen here. So this is a script that is rendering 1,000 asteroid instances. It's something like 15 million triangles, which is a lot. And so the way this is working is there is a single call that is being used. You can see we've got 15 million triangles, but we've only got 60 batches, which is that's actually pretty all right. And the cool thing is we can actually go much, much higher than this. So I've been playing with this, posting a few things on like Twitter and Facebook, trying to come up with a good way to do this. And you can see this is a lot of asteroids, like 5,000. I hit 2D. So yeah, we're rendering 75 million triangles, and we're still getting 70 FPS. So this is fast. The problem is it's not really what we want. It's literally, I can show you the script here. It's literally just creating it's creating a new instance in a cube and then drawing each of those. So we're using this Graphics.DrawMeshInstanced, which is using a instance shader. So that's a special style of shader. I literally just created one by going to create shader standard surface shader instanced, which will get you an instanced version of your surface shader. Which allows you to do stuff like this. So this is really useful if you have a lot of similar objects that aren't going to change, so grass or trees or buildings or asteroids. So what we're going to be doing, I hope, is building something that can automatically render these asteroids at close distances. So we're going to want to create new ones as they come into view, and then remove the old ones as they leave. And then we just want to, we already have our shader, and you can see it kind of fades out here. What we want to do is inside of that faded out zone, we want to replace all of that faded out stuff with actual rocks. So that's hopefully what we're going to be starting here. I don't know how far we'll get. I don't, no idea. Never done this before. So I got this working yesterday night, and I've been just mostly testing performance and seeing what I can do with it. And so, yeah, we'll have to see. So I think for now, we're just going to want to start with a instanced asteroid do we want to call it a renderer? Sure. So this is going to actually handle rendering a single instance of an asteroid. The thing is you can't mix models or anything like that. It can only do one thing. It's every single model here has the exact same material and the exact same mesh. The fact that they all share a rotation and a position and stuff, we can change that, and we probably will change that. But as far as the rendering goes, it's all shared. So we're going to need a mesh. I'm actually just going to copy. Oops, that's wrong. Going to copy everything from here. So we're just going to get a mesh material, or a mesh and a material. And then I'm also going to have it execute an edit mode. This way it will compile and run in our editor, which means we can actually see what we're doing instead of just starting the game to try to figure what's going on. So I think that'll be useful. We'll figure out if we want that. But we have our mesh, we have our material. I'm going to assign an integer, and this is going to be our maximum asteroids. So we cannot exceed this. Instance rendering is topped off at 1,024 instances. So like I have 1,000 here. If I go in here and up this to like 20, and then I have to shake it just because of the way I have it updating, but they all go away. and that's because we're trying to render too many, and we get this exception. So matrix list out of range because we're doing bad stuff. So we need to keep that in mind, and so we need to put a limit in. There's also going to be a limit simply because I don't want to kill people's PCs with this, and because this is going to determine the density of our asteroids. So maximum, I'll say 1,000 for now, so we won't exceed 1,000, and I'll make this a range between 1 and 1,024, and that way we absolutely cannot exceed that. I'm going to drop it down just 1 because I think, yeah, so we can't go up to 1,024. That's our limit. So that's our maximum number of asteroids. We're also going to have a float instantiate distance. So this is going to determine how close something has to be before you instantiate it. And that is going to be, we'll default that to 500. Remember, we're working with planets, so we're going to have big numbers. And so what this is doing is this is saying if there is room to build new asteroids, and then build something along this border. Don't know where yet, but somewhere along that. And then we also want an instantiate destruction. So this made sense to me as I was thinking about it. But I'm wondering if we don't want to do this. What if I've got a better idea. We can use a dot product to actually determine, so there's a rotation around a planet. Usually it follows the rotation of the planet if I'm not mistaken. And so if we take the position of the planet and the position of the player, everything on one side of that line is going to be moving away, and everything on the other side is going to be moving towards the player. So what we can do is just automatically instantiate things on that one side that's moving towards the player, and then delete them when they get too far away on the other side. So all we need then is just a radius, and we'll make it 500. But we also will need a transform of our planet. And so that planet transform, that's what's going to form our line. Do I want to give the planet and the player? And this is actually going to be a ring, so this planet transform, that's actually going to be the same as this instance, so we don't actually need that. And we can probably get it from the camera. Yeah. Okay. So here's what we're going to do. We are going to calculate a vector 3, and we want this to be our asteroid heading. And so this is going to be where they're heading. And so to get that, let's take the cross product. Cross product between our player and our planet. So we're going to do a camera dot main dot position. Transform dot position. Sorry. And subtract that from this dot transform dot position. And that's going to get us one of our vectors. And then I want to calculate the up vector, which we can actually just, let's use our current up vector. And that way, if we want like multiple rings, like in an X or something, we should still be able to do that. So remember cross products, if you have the three finger rule, if you have 3 fingers, if you give it 2, it'll get you the third. And so that's what we're doing. We're giving it up, and we're giving it the direction towards our planet, so that will give us the direction our asteroid should be heading. So we should be able to then instantiate things. So I'm going to want a list of matrix 4x4s. So a 4-dimensional a 4x4 matrix is what you use. It pretty much is your transform, and that's going to have your position, it's going to have your scale, and it's going to have your rotation. It's 4-dimensional because of a number of reasons. I'm not going to go into those right now because that's more of a graphics rendering reason than it is relevant here. So this should just be our asteroids, I guess. And so we can make a new list of our matrices. And then, do we want to always ensure that we have our maximum asteroids at all times? Because then we can do while our asteroids dot count is less than our maximum asteroids. Then we want to create new asteroid with an asteroid heading. Yeah. And that should just build us a new asteroid. And so this will just ensure that we always have whatever our maximum number of asteroids is, that will get that. And so, assuming we have an even distribution of them, we should be good. So now, what do we need to do? Good question. So that create asteroids, I think we can... Well, actually, if we implement this, we'll already have something we can run. We just need to actually render them. So I'm going to pull this out, DrawMeshInstanced, and we'll just stick that there. We can replace our instances with our asteroids. And now that should work. So once we finish this function, we should be able to render any number of asteroids, and they should, assuming everything is working correctly, be randomly distributed. So one thing I'm thinking is we may not actually, initially, I don't think we want to create them like this. We want a separate way. And the reason for that is because if we do this, they'll all start on that boundary, which is going to be harder anyway. But also, we don't want everything to start away from you and then procedurally come towards you. That doesn't work. So we want to distribute things randomly within your sphere. So we can do that while loop again. Create new asteroid. What do we want to do? Create it when it's near something. Create new asteroid random, I guess. I don't like that name at all, but we'll go with it. And so what this is going to do is we're going to need our center, which is going to be our player. So for this, I'm just using our camera main, which is just going to be the main camera in our scene. Every scene should have a main camera. If it doesn't, this won't work, which we can fix later. I'm just doing this fixing that is easy. Getting all of this to work is hard. So we're going to get it all to work, and then we're going to go and clean it up. So we've got our camera main dot transform position. And this will be our center. So we're just storing the center of wherever we're creating stuff around. And then what we want to do is do asteroids.add, and we're just going to add a new 4x4 matrix. And the way you make those is something like this. So we can just copy and paste again. So what this is doing is this is called the matrix 4x4 I don't know what that T stands for. TRS. Translation. There you go. Translation, rotation, and scale. So this is just your standard matrix for positioning. There's a bunch of other matrices that you can use. You can create a projection matrix this way. If you do that, this won't work. This definitely won't work. So what we want is we want our center and something else and something else and something else. I'm going to just keep the rotation and scale. Those are also easy to fix. I don't want every asteroid to have its own unique scale or its own unique rotation. We might have like a few rotations and a few scales that will cycle through, and actually, since we're storing these, it might be easy to actually modify them. But for now, I don't want to start messing with them. It'll get weird. So we're creating everything at the center, and this actually should work. If I bring the asteroid renderer here, I should be able to attach this and our instance material. One thing that you absolutely have to do, you have to make sure you attach your material, and it has to be an instanced material. If it isn't, you won't get anything. So like right now we have all these asteroids. If I replace this with just a normal shader, they all go away. And there's not going to be any good explanation for this. It's just going to not be there. So you don't want that to happen. So remember that you need a special shader for this. So why is this counting up? That must be we don't have null checks or something. Probably because our mesh and our material weren't set initially. So we have a ton of asteroids. Doesn't look like a ton, but it should be. This won't actually affect anything because we don't actually clean up. But if I look at this, we have 15.1 million triangles again. They're just all right there. And so with that, now we can actually start spreading them out, give them motion. If they get outside of our radius, then we destroy them. So that destruction thing is going to be hard because it means we're going to actually have to... The destruction means we have to iterate over that entire list. We're going to have to do that anyway, actually. So never mind. For each matrix in our asteroids, let's not call it a matrix. That's a bad idea. Let's call it an asteroid. And then we can do some things. There's not much that we can do here, is there? No, I don't think there is. Multiply vector. No, we don't want to do that. Multiply point. Multiply point. I'm going to actually just reset this transform. The translate rotation scale. I don't want to do that. That sounds like a bad idea. But I think it's the best way. We don't need the transpose. That's something else. Okay, we may not want to do this. And the reason I say that is because that doesn't give us what we need. Gives us a matrix, But then if we want to actually move things, we have to do it ourselves, and that's kind of gross. So one of the examples I can give is we can move it along. Can we actually set this? I don't think so. Yeah, okay, we can't even set it there. Okay, bad example. But anyway, we need to actually know how to modify that matrix, and that's not something I want to deal with. So this is not going to store matrices anymore. This is going to store asteroid information. So we need a new public class. We'll do an asteroid data, which I don't really like that name, but we're going to go with it. We're going to give it a vector3 of our position and a vector3 scale and a vector, quaternion of the rotation. And I think we can, because we're doing this, let's add a few other things. So we'll add our speed. We're going to want some speed there. So this way we can have multiple asteroids moving at different speeds. I was just going to have them move all at the same speed and then just have layer a few of those over. This is better. So position, scale, rotation. We need to do a few things. Don't know what. Well, first, that asteroids still exists. We need to make that not happen. So we need our asteroid data, like so. And I'm also going to add a matrix there, and that way we can store it if we need to. I think that'll just make this easier. Or actually, we can just get it and return matrix position, rotation, scale. And so this is just going to be a quick getter, so we can actually return our matrix. So that just makes it super easy to get. And we could actually use it as a constructor too if we wanted, but I'm not going to, because then we'd have to decompose that matrix, and that's gross. So we're going to do an asteroid data. Yeah, this will work. Let's create a public constructor, and we'll give it our position, our scale, and our quaternion rotation. And then also we need a float for the speed. So this is all boring, but once we get it done, we should be able to actually start manipulating this, because from this information we can create the matrices we need to draw. It may not be the most optimized way of solving this, but it will be a way of solving it. And then we can go back and optimize things after we get that working. Because I think getting it working is going to be one of the harder parts, and then once we get that, I think we should be able to actually start at least wrapping our heads around how to solve the problem. I gave those in the wrong order. Here we go. Cool. So now everything works. We just can't render our asteroids anymore. So we need a list of our matrices, which actually, so this is going to be slower. There's no real reason to do this. But if I, where is it? Select. Can't select what? Hold on. Oh, I must not have link. We're gonna use link for this, just because it will be a quick way to get this done. I'm doing a lot of things quick because doing it the right way is, first off, gonna take a lot of time, and two, it's going to just make things harder to like understand, because if we try to start optimizing this too soon, it's not going to make a lot of sense. So we're going to select the matrices out of our asteroid list, and then we're going to convert that to a list. Yeah, that's not a good idea, but we're going to do it. So don't do this in your actual game. This will be slow. But for now, for just testing, it's a really quick way of creating and selecting a new list. We did it in a single line instead of doing a bunch of other stuff. So what we want to do is, for all of our asteroids, we should be able to increment the position by some random amount. I'm going to do it by the asteroid heading, just so they all go in the same direction. So asteroid heading times the asteroid speed times the time delta. So right now these won't move fast at all. I'm going to do a random here. Dot range. We'll do between like 2 and 10, sure. And I'm going to make it a float, just so we get floating point precision there, instead of, by default, it would have chosen an int. We need to specify the namespace, because I imported system, which I can actually take out. We don't need that. And then we just need another parenthesis. Cool. So that will create our new asteroids, and they should move now, and they should do that automatically even in the editor. So I guess we can see if that works. I'm gonna let it compile, and then hopefully we'll see something, or it'll crash. Also an option, very much a possibility. Leaning towards the crash at this point. It shouldn't take this long. Yeah, that's kind of weird. I may have broken it. Send help. What would cause that? So we definitely don't have an infinite loop, just making sure of that. We do actually add to our list. If we didn't, we might have an infinite loop, but that doesn't seem to be the case. Yeah, I'm going to restart Unity. I will be right back. Okay, so I have gone through and edited everything. So we have an asteroid, and it is now attached or deactivated right now. We'll see if this crashes it. If it does, our script is broken, which could be a whole bunch of issues. So, yeah, no? Hold on. Well, that's interesting. It's not really what I expected, but it's interesting. We have a very long immobile string of asteroids, which is kind of what I was expecting, actually, but it's not where I was expecting to see it. So apparently, oh, okay. That goes on for a while. Not sure what's going on here. Just to check. How many triangles are we rendering? 5,000. I think that's because these are out of the render distance. Because I would expect more than that. Which kind of makes sense. Okay. What? They're gone. What? Why are they gone? What have I done? Something horrible. But what? Why wasn't it updating all the time? I wonder if this is due to our execute and edit mode. I bet that's related. One other thing I'm going to do is we are going to do, we're actually going to remove this. And we're going to do a replace asteroid. And so instead of deleting and removing them, when they get out of range, we're going to replace all the values in there with the new ones we want. So this no longer, it cares a little bit about the heading, but more importantly is the asteroid data. So we pass in our asteroid, do all of that fun stuff, and then that will eventually recreate it. For now, is that a good idea? I don't think that's a good idea. We're not going to do that. Okay. I'll figure that out later. We don't really care about that yet. But what we do want is if our asteroid let's see. I think we want this heading to be normalized, so that's what I'm going to do. Doesn't return anything. So we need to do it like this. Normalize our vector. We've got our asteroid here. If it's, we need to think about how to solve this. If its position or distance is greater than the radius, and it's heading away, is that how we want to do this? What if you're going like with the flow of the asteroids? And so things are, but you're going faster. So things are being created and then deleted. Because you should be able to go in both ways. That's going to be hard. We're going to have to figure that out. I don't know. But for now, if the position is greater if the position minus our current camera position, so we're going to do camera main transform position, if the difference between these two has a distance, or a magnitude rather, greater than our radius, then we want to replace the current asteroid with something else. And we can just pass in our heading as well. And that should do it. So for now, we're going to replace it by just doing asteroid.position equals camera main.position or .transform position. That's probably a bad idea, but we're going to see what happens. So, where is our camera? Oh, that's probably part of the problem from our previous test. I hadn't moved our camera to where I thought it was, sort of out in the belt. So currently, this is too big. Like it's huge. The scales we're working on are not great, because as you see, everything disappears. That's because our far render distance is too short. So I've just been cranking it up. We may have to do some other stuff, because when we do that, we lose some precision, which isn't good. But for now, we don't have a choice. So anyway, I've been doing that. We have our asteroid instance render. If I start this, we should see a number of asteroids spawn at our... Yep. At our position. So all of those spawned at the same time, and they just have a different speed. Just reduce the radius. Unfortunately, I zeroed it first, so they'll start over, but they should wrap. That's sort of what I'm expecting, is they'll get out of bounds and then they'll come back. And their speed shouldn't change. Yeah. So they should overlap and pass and things like that. So this is kind of what we want, but we want this in a ring. So we want to kind of wrap this around our planet, and we want it more than one dimensional. So we need to figure out how to do that. And I don't know how. I think, let's see, we've been going for 45 minutes. So let's cut it here, and we'll pick up and actually wrap this around our planet in the next video. I think that makes sense. Otherwise this will start running very long. So I'll leave it here, and then I will see you guys in the next video. So if there's anything any feedback you have, or anything you want to suggest we try, let me know in the comments. I'd love to hear it. But until next time, see you, Internet.